Welcome to your third flip video. This is 2.0c, roots. First thing we're going to talk about is a radical sign. On your paper you need to write down radical sign and underline it because it's a vocabulary word. And let's go ahead and draw the symbol first. A radical sign looks like this, and I'm sure you've seen them before. The definition is that a radical sign indicates a root. You may not know what a root is yet, but we'll get there. As another definition, I just want you to know how we read these. So go ahead and write down this example right here. And I want you to do a dash, and then in quotation marks, like you're reading out loud, we're going to write square root of A. So that's just how we read it. When you see a problem looks like this, you say the square root of A. One last vocabulary word is radicand, and before you move on, make sure you can say radicand. And the radicand is the number under the radical. Under the radical. Okay, so you're probably thinking to yourself, oh, okay, so the A here is called the radicand, and I read this as the square root of A. So A in this example is the radicand. Okay, here's the most important part of the video. I need you to write down this whole sentence. The square root, this is a very important part. The square root of a number is the number that, when multiplied by itself, is equal to the radicand. Okay, here's an example problem to do underneath the sentence you just wrote. Let's review the parts of this. So first, this is called a radical, this is called a radicand, and the way we read this problem is the square root of 144. Now, the square root of 144 is the number that when multiplied by itself is equal to the radicand. In our case, is 144. So we're thinking to ourselves, what number times itself equals 144? And hopefully in your brain you're starting to think about the number 12. Now I'm going to add something to this, and don't get tripped up by it. I promise it'll make sense in a second. We're not actually going to just leave this as 12. We are going to say positive or negative 12. In the next frame, I'll explain to you what I mean. Okay, here I'm going to prove what I just said about that plus and minus thing. So, since 12 squared in expanded form is 12 times 12, and that equals 144, and negative 12 squared equals negative 12 times negative 12. That also equals 144, comma, then the square root of 144 is actually positive and negative 12. That's why we write that. If both options are good, we can write positive, negative 12 with that sign, with a positive sign and a negative sign sitting on top of each other. That means that both answers are correct. Here's where these square roots get fancy. So we've got these perfect squares. And I'd like you to write this down in your notebook as well. Perfect squares have square roots that are integers. You know an integer is a negative or a positive whole number. So let me give you some examples and make sure you write these down as well. The square root of 1 is a perfect square because 1 is the answer. The square root of 4, positive or negative 2, is the answer. So the square root of 4 is also a perfect square. The square root of 9 is a perfect square because its square root is positive or negative 3. I hope you are seeing a pattern. The square root of 16 is positive or negative 4. And the square root of 25 is, you guessed it, 5. See if you can do the next two on your own. Square root of 36, square root of 49. Pause the video, fill it in, and then check back with me after you are finished writing in your answers. Okay, hopefully you're back, you've paused it, and you have found that the square root of 36 is a perfect square because you get the positive or negative integer of 6 for that answer. And also, 49 is a perfect square because the square root of 49 is positive or negative 7. We could go on for days. Let's not. Okay, as you might have guessed, there are non-perfect squares as well. Non-perfect squares have square roots that are irrational numbers. So an example of this would be the square root of 2. As you can see, if you type in the square root of 2 into a calculator, you get this huge long decimal. That's an irrational number because it doesn't end, it keeps going on, and it's just not a nice clean integer like we're used to, those whole numbers. So these are non-perfect squares. Another example of that is the square root of 5. You're going to, again, get another decimal because there's not a good clean integer whole number that multiplied by itself equals 5. All right, you did it. Good job.